Dear students, today's topic is polarization of light. We know that light is an electromagnetic wave. According to Maxwell's electromagnetic theory of light, light consists of electric vectors and magnetic vectors vibrating at right angles to each other so that the disturbance produced travels in a direction perpendicular to both electric vector and magnetic vector. Electric vector and magnetic vector, suppose they vibrate at right angles to each other. Then the wave propagates along this direction. This is the direction of propagation. So, electromagnetic wave is transverse in nature. What do you mean by transverse nature? Transverse nature means the direction of vibration of the particles of the medium, or here electric vector and magnetic vector, at right angles to the direction of propagation. Such a wave is called a transverse wave. So, light is also a transverse. Light is transverse in nature. So, light and electromagnetic wave, this theory was proposed by Maxwell. Now, light, see, all the optical properties of light are mainly due to electric vector. That means, electric vector is responsible for the optical properties of light. Therefore, light is also called as electric vector is also called as a light vector. Thus, the optical properties are explained by considering only the electric vector, which is responsible for all the optical properties of light. Now, what is polarization? This polarization of light, it's nothing but restricting the vibrations of the electric vector to only one plane. The ordinary light, it emits light in all possible directions. The molecules or the atoms of the given source of light, they emit light waves in all possible directions, so that the electrical vector of the waves emitted, the waves are independent of each other, all the waves are vibrate independently, so that the electric vectors of those waves, they will have the vibrations, they will have the random vibrations, and they will have the random orientations with respect to the line of propagation or the direction of propagation. So that the ordinary light, if there is a source of light, it has got vibrations in all possible directions. These are the vibrations. Vibrations are nothing but the electric vectors. We have electric vector, vibrations of the electric vector in all possible directions. This is the representation of an ordinary source of light. It sends out light waves in all possible directions. So let this one be the direction of propagation. This is the direction of propagation. So the electric vectors are randomly oriented with respect to the direction of propagation, and the distribution of electric vector is symmetric about this direction of propagation. In an ordinary source, the distribution of the vibrations of the electric vector is symmetric about the line of propagation. Such a light is called unpolarized light. This is the unpolarized one. Light having vibrations in all possible directions, the distribution is symmetric about the line of propagation. It is unpolarized light. By some technique, it is possible to eliminate this symmetric distribution of electric vector, vibrations of the electric vector about this line of propagation. By eliminating the symmetric distribution, we get the light having vibrations restricted to only one plane, to only one direction. Such a light is called a polarized light. So what is polarization? It is the phenomena in which the symmetrical distribution of electric vibrations about the line of propagation is eliminated. Such a light is called a polarized light. And a polarized light is usually represented like this. One more thing, this unpolarized light is also represented like this. This is also the representation of unpolarized light. Unpolarized or partially polarized. The polarized light is represented like this. This is the representation of polarized light. The difference is here the vibrations of the electric vector is in a plane parallel to the plane of the paper. Say for example, suppose this is the plane of the paper. Here in this case, in this polarized light, suppose this is the direction of propagation, then the vibrations are parallel to the plane of the paper. And in this case, the vibrations are perpendicular to the plane of the paper. Direction of propagation, vibrations like this. Such a polarized light represented like this, and vibrations in the plane represented like this. These two represent the polarized light. What's the difference? Vibrations parallel to the plane of the paper. Here, vibrations perpendicular. In both the cases, vibrations are restricted to only one plane. Here the plane parallel and the plane perpendicular. All other vibrations are eliminated. A device is required. The device used to produce polarized light is called a polarizer. Polarizer is prepared using certain crystals having the property of producing a polarized light. This is about unpolarized light and a polarized light. In a polarized light, there are three types: plane polarized, circularly polarized, and elliptically polarized. These are the three types of polarized light. What is a plane polarized light? See, a plane polarized light is one in which the vibrations of the electric vector is in a plane perpendicular to plane of propagation, and the projection of the tip of the vector is along a straight line. Such a light is called plane polarized light. It is denoted like this. The vibrations of the electric vector is along the straight line. The tip of the vector, the projection of the tip of the vector is along a straight line. The electric vector vibrates in a plane perpendicular to the plane of propagation. So this is the plane in which the electric vector vibrates. It is perpendicular to the plane of propagation. It is the plane polarized light. Second one is circularly polarized light. Here, the vibrations of the electric vector is in a plane perpendicular to the plane of propagation, and that electric vector vibrates with equal amplitudes, and the projection of the tip of the vector is along a circle. Such a light is called a circularly polarized light. The electric vector, it vibrates with the tip describing a circle. It vibrates with equal amplitude, and the projection of the tip of the vector is along a circle. Such a light is called circularly polarized light. So this is plane polarized. This is circularly polarized. Third one is elliptically polarized light. See here, electric vector vibrates with unequal amplitudes, and projection of the tip of the vector is along an ellipse. The tip of the vector describes an ellipse. Such a light is called an elliptically polarized light. Here, the electric vector vibrates with unequal amplitudes, and the tip describes an ellipse. This is elliptically polarized light. These are the three types of polarized light: plane polarized, circular polarized, and elliptically polarized. Now let us consider the plane polarized light. A plane polarized light is produced by different methods. The methods are by reflection, by refraction, by scattering, by double refraction, and by selective absorption. These are the 5 methods by which a plane polarized beam can be produced: by reflection, by the method of refraction, by the method of scattering, by the method of double refraction, and by selective absorption. This method, by selective absorption, also called as dichroism, double refraction is also called as birefringence. These are the 5 methods to produce a plane polarized beam. First method is by reflection. This phenomenon was discovered by Mallows in 1808. While performing experiment, Mallows observed that when a light is incident on the surface of a medium such as glass, say glass or water, when light is incident on the surface of a glass or water, then light gets partially reflected and partially transmitted. So this is the normal at this point of incidence. This is angle of incidence, say I. And in this case, he observed that the reflected ray was found to be partially polarized. See, partial polarization represented like this. The ray was found to be partially polarized. And then he increased the angle of incidence. As he increased, what's angle of incidence? Angle between the incident ray and the normal. This is the angle of incidence equal to angle of reflection. This is angle of refraction. Sin I by sin R. Nothing but refract index of this medium. It is Snell's law. Then in the experiment, as he increased this angle of incidence, he observed that the amount of polarization was increased with the increase in angle of incidence. As I increases, the amount of polarization was also found to be increasing. And at one particular angle of incidence, the reflected ray was found to be completely plane polarized. At one particular angle of incidence, the reflected ray was found to be completely plane polarized with vibrations perpendicular to the plane of incidence. That angle of incidence is called as polarizing angle, denoted as theta p. Polarizing angle, nothing but the angle of incidence at which the reflected ray is completely plane polarized. It is the polarizing angle. Sometimes it is denoted as IP also, either theta p or IP. And a scientist called Brewster, he observed that at this polarizing angle, the reflected ray and the refracted ray are at right angles to each other. At the polarizing angle, the reflected ray and the refracted ray are at right angles to each other. And Brewster also stated that the tangent of the polarizing angle is always equal to the refractive index of the medium. Tangent of the polarizing angle equal to refractive index of the medium, and this law is called as Brewster's law. This is how a completely plane polarized beam is produced by the method of reflection using the medium like glass or water, transparent medium such as glass or water. What is Brewster's law? Tangent of the polarizing angle is equal to refractive index of the medium. This is about the production of plane polarized beam by reflection. The second method is producing plane polarized beam by double refraction. Refraction scattering are not discussed in your syllabus. So let me consider the next method. It is double refraction. What is double refraction? Certain crystals, they show this phenomena. The crystals such as calcite, quartz, they exhibit this phenomena, double refraction. Double refraction means whenever a light is incident on this crystal, that light gets split up into two rays. They travel in different directions. The light splits into two rays, and those rays are plane polarized in two mutually perpendicular planes. The two rays obtained after this splitting, after this double refraction, are found to be completely plane polarized with vibrations at right angles to each other. Vibrations in the planes perpendicular to each other. Suppose this is a crystal. The light is incident on this. Light splits into two rays. With vibrations, one having vibrations parallel to the plane of incidence, other one having vibrations perpendicular. This ray is called as E ray. E ray nothing but extraordinary ray. This one is called O ray, nothing but ordinary ray. The rays obtained after double refraction are called as extraordinary ray and ordinary ray. What the difference is? Both are plane polarized, but the vibrations are vibrations of the electric vector in two mutually perpendicular planes. One is having the vibrations parallel, other one having perpendicular. This is the method how the plane polarized beam is produced by double refraction. But here we have two rays, two plane polarized beams, two plane polarized rays. So if we need only one, then one of these two can be removed by the method called selective absorption. By using some technique, one of these two rays can be removed. That method is called selective absorption or dichroism. This is how a plane polarized beam is produced in selective absorption also. This is double refraction. And what about these two rays? These two rays, they differ in some properties. Ordinary ray, which obeys Snell's law. What is Snell's law? Sin I by sin R is equal to N. Sin I by sin R is equal to N. Angle of incidence, R is angle of refraction. Sin I by sin R is constant refractive index of the medium. Ordinary ray obeys Snell's law, whereas extraordinary ray does not obey Snell's law. Ordinary ray travels with the same speed at all the points or in all directions of the given crystal. Speed of O ray remains same, whereas E ray travels with different speeds in different directions. Refractive index of the crystal same for O ray in all directions, whereas refractive index different in different directions for E ray. And these are the difference between ordinary ray and the extraordinary ray. And the double refraction phenomena is observed only in certain crystals. And depending on this or not depending on this, the crystals are classified into two groups such as isotropic crystals and anisotropic. Only anisotropic crystals exhibit this double refraction. Isotropic crystals, they do not show double refraction. Isotropic crystals are the crystals having the properties same at all the points. See, whenever light passes through that crystal, the light has got same properties in all directions and at all the points of the crystal. Such a crystal is called isotropic. Isotropic crystals, they do not show. There in the isotropic crystal, the arrangement of the molecules or atoms is periodic one. So they do not exhibit double refraction because the light incident light, the light vector, it has got some properties same in all directions. So no double refraction. Example, glass, water, these are uniaxial crystals. Sorry, these are isotropic crystals, and they do not exhibit double refraction. And all crystals which are perfectly cubical in shape are isotropic. They do not show double refraction. Anisotropic properties are different in different directions or properties are different at different points. So the anisotropic crystals show this double refraction. In anisotropic crystals, again still there are two more types: uniaxial crystals and biaxial. Uniaxial means crystals having only one optic axis are called uniaxial. Crystals having two optic axes are called biaxial. Only uniaxial crystals, they produce two rays, E ray and O ray, by the method of double refraction. Uniaxial crystals, they produce E ray and O ray by double refraction. Calcite, quartz are the uniaxial crystals which exhibit this phenomenon of double refraction. In case of biaxial crystals, only extraordinary ray is produced. Only E ray is present there, but O ray is not present. This is about the types of crystals which produce the double refraction. And with this, I stop here. Let us continue the next topic in the next class. Thank you.